Alrighty, cool. So how would we do part A for this one here? What does part A say? Find what? F of 4 pi over 3. So what would I do? Yeah, so what do I do? What does this mean? You plug 4 pi over 3 into what? Into sine. Now in this part of the test you have a calculator, so I'm not going to use one. So it's going to require my knowledge of the unit circle. So f of 4 pi over 3 is equal to 2 times the sine of 4 pi over 3. Does anyone have any questions so far? Is this okay? Any questions? Yeah, because this means f of this, whatever goes in x goes in here, right? So in this case, x is 4 pi over 3, so we just plug it in, right? So now we need what? Yeah, we need to know the sine of 4 pi over 3, right? And for that we need the unit circle. So I'm going to draw the circle here, okay? And we're going to have a quiz on it tomorrow. Yes, it is. Absolutely. So we know 1 pi over 3 is how many degrees?
60.
60. Very good, Gustavo. So like this would be pi over 3, right? So how many pi over 3s do I want? I want how many of them? 4, right? So this is 60 here. If I add another one, where would that put me? What is 60 plus 60? 120, which is about like here, would you say? That's about there. It doesn't have to be, and this is 2 pi over 3. See what I'm doing? I'm just adding, this was 1 pi over 3, this was how many?
2 pi.
2 pi over 3. And that would be what? 120, right? If I had another 60, where would that put me at?
180 degrees.
3 pi over 3, which is what?
Pi.
Which is pi, right? Which is 180. Do we agree? And now, how many? I want one more because I want 4 pi over 3. So this is another way of doing it with the unit circle. You could just count the fractions, okay? Which is going to be like somewhere here, right? This is 4 pi over 3. But we know it's how many more degrees? It's 60 degrees more, right? So the point is, we know that the real angle is 240, right? But what's the reference angle?
30 degrees.
This is what? 60 over here, right? So the point was I needed to get this one, and now I fill in my triangle. So I have a what? This is my triangle. This is 60 here, right? And then what's across from 60?
-1/2.
It's square root of 3 over 2 is across, right? It's okay. And then what's across, and this is 30, right? Oops. And this is 90, true? So what's across from, if this is confusing, you block this out. What's across from 30?
Over 30 is 1/2.
Yeah, 30 is across from 1/2 over here. Okay, and if you don't know, we could write them down. So 60 is across from root 3 over 2. If you don't know these, write these down. 30 is across from what?
1/2.
1/2. 45 is across from what? Root 2 over 2. Okay, so now I have this, and which one do I want? I want sine or cosine. And what distance is that?
Y.
Y. So where's the y? Is y up and down or left and right?
Up and down.
So it's this one here, but if you notice, you see how it's going downwards here? It's negative, and the x is also negative. Thank you, Gustavo. Because it's below the x-axis, the y value is negative here. So then this whole thing becomes what?
2 sine.
So it's 2 times what?
Sine.
Negative what?
4.
3 over 2. And what does this become here? The 2's can cancel, true? And what do we get? Negative square root of 3. And this is what f of 4 pi over 3 is. Notice, I didn't use a unit circle. Oh, I did. I made it, right?
Yeah.
And that's really the goal. That's where we all want to be. Now, I'm going to give you a note card. So if you write your circle, that's cool. But you want to be able to memorize it as well. Here we go. So that's one part. If you notice, I have to also find what? G. So we're going to do G. Now G, yes. So G of x is equal to what? the absolute value of f of x, right? So g of, oh wait, I messed up. What am I plugging in? 4 pi over 3, right? And then what do I get? I'm going to plug it in, and it's going to be the absolute value of f of 4 pi over 3. Do we agree? And the cool thing is, this is messy, sorry. This is g of 4 pi over 3, sorry. The cool thing is, don't we know this already?
Yeah.
So look, on the test, I'm going to give you one that's going to be connected to one that you just did. Okay? All you have to do is do something to it. I'm going to tell you right now what it's going to be. I'm either going to tell you to take the absolute value, the square root of it, or square it. It's one of those. I know. Don't freak out. So, what do we get? What was this here? It's the absolute value of negative root 3, right? And what does that give me? Positive root 3, so it becomes positive square root of 3, and this is my answer here. Okay. Any questions on this piece here?
No.
Okay. I think plugging in is pretty straightforward. People tend to make mistakes or get points off because they don't. They just plug it in the calculator and they get 1.732. They round off. You want to leave it at square root of 3. And if you notice here, I'm going to zoom out. I even have a scoring guide for you. It says here, you get 1 point for this part here, 1 point for f of 4 pi over 3, and 1 point for g of 4 pi over 3. Okay? Alright, so now we're going to do part B. Let's go ahead and read part B. Jennifer, can you read it for us, please, miss?
Graph out a sketch of f of x and g of x below. Make sure to label or scale the x's where you did.
Okay, so we know how to draw f of x, right? What is f of x? It's just a sine function with an amplitude of what? 2. That's really easy. So equilibrium is at 0, right? So I know it's a 2. Equilibrium is at 0. And sine looks like something like this, true? And the amplitude is what? 2. So that means the roof or the ceiling or the max is going to be at where? 2. So I put the ceiling at 2. I don't care if you draw these. It's totally fine. Okay. And the bottom or the basement is going to be at negative 2, right? And then we draw sine. And what's the period of sine naturally? It's 2 pi. You see my rectangle? So you're going to squeeze this graph in here. Ready? You know it starts here and it ends here. And you draw your sine. And notice over here, I would not take off points for this. Even though it's slightly imprecise as I make fun of my graph. Why is it imprecise? Why? This looks off a little. Why? Yeah, like you see how this is kind of bent, right? But look, clearly I intended for the minimum to be at negative 2 and the max to be at 2. Even if it's off, I don't care if you have a shaky hand. Okay, that's okay. It's still fine. And now we have to label it. Notice, you have to label or scale it. You have to label your axis or your axis. Your axis. Right? So, this is, wait, which function is this? F of x. Please label f of x above. Now, on here we're going to label what? G of x. So, now, look, again, I'm going to ask you to do something based off of this. You can use a calculator for this one, but hopefully you remember what these operations do to the graphs. G of x is just the absolute value of what? What does the absolute value do to a graph?
Take away the negative.
Well, that's the square root. It takes it away. What does the absolute value do? It reflects all the negative y values where? Over the x-axis, right?
It's going to be lumps.
Perfect. It's going to be lumps. So it's going to be 1, 2, right? Now, notice, some of us might be inclined to draw the negative side too, right? Why is this unnecessary? Not going to be there, but we'll just do it for fun, right? And then, whereas 2 pi was like, what about here, right? Do we agree? And halfway was like pi. We'll just do that for fun. Okay, so now this one's the same, right? It goes up to 2. But then what happens here? Does it go down? What happens? It's what? It flips what? Upwards like this, right? And and then it would what?
Keep going.
It would continue. Oops. Notice here, you see how I'm making sure that it's hitting the top here, the max at 2? And what would this value be here?
That would be
3 pi, right? Because you see how it's going by pi? Okay. Excellent job. And this would continue. If you'd want, you can just throw on an arrow here to indicate that these continue in the same fashion. Here, you could do the same thing for sine. They do not end there. Remember, it's just a sketch. And here is a breakdown, the scoring guide. Yeah. Oh, 1 second. You get 1 point for the correct sketch of f with axis labeled, so the amplitude is clearly determined. And you get 1 point for the sketch of g with the axis labeled, so the amplitude is clearly determined. Okay, 2 points each. Gustavo, question.
So do a square root.
Yes.
Do you have asymptotes and there would be a form between the...
Let's go ahead and do that. Gustavo says, what does this one look like, right? We know sine normally looks like what? This, right? What would the square root do to all the negatives? So it would basically look like this instead. And then what? See that?
Would it have asymptotes?
No, not asymptotes, just breaks. Breaks. There'd be whole pieces. Because there's all of these are points, right?
Yeah.
So there's an infinite amount of places where the function is not defined.
Oh, so that's
Jump. You call that?
continue?
No, it does not continue. This is called jump. See how it's jumping from here to here?
Yeah.
That's called jump discontinuity.
Jump discontinuity.
Because it's like jumping from here to here. That's called the jump discontinuity. Good question, Gustavo. Thank you. Let's please flip. Wait, before we move on, does anyone have any questions with this one here? All right. What happens if I squared it? What is about sine squared? What would that look like? These would be reflected, but these would be what? Like maybe a little taller, right? That's basically what it's going to look like. So it's almost like this one, just a little maybe taller. Cool? All right. Oh, does that make sense or no? Oh, it's right here, Cheryl. My apologies.
It does that because it's making it bigger, right?
Yeah, you're not only like, because when you multiply a negative by a negative, what happens to the negative values? Positive. And if you multiply a number greater than 1 by itself, it makes it bigger. Okay? So just as a little footnote. Okay? Wait, you guys know what a footnote is? Hold on.
Yeah.
What's a footnote?
It goes under the...
Wait, one person. Wait, what's a footnote? Yes.
It's like usually a footnote to a book where like tell you the explanation of something.
Right. It's like it's a tiny little piece of a note that helps explain the larger whole of what you're trying to analyze. Okay. A footnote is just like a little note off to the side. You know when you're at a restaurant and they have those little stars that say this dish is hot? That's a footnote. Don't burn yourself.
Hey.
Okay.
Does the amplitude increase when you square it?
Only if it's bigger than 1. In this case, in our case, it would because this would be 2, right?
Yeah.
So that would make it. It would make it. Yes, perfect. Way to go, man. Good job. All right, and finally, part C. Let's read part C. Barbara, could you read it, please?
Compare the domain of f to that of the domain of g.
Wait, hold up. So I have to compare the domain to f to g. Okay, keep going. That's awesome.
Is the absolute value modify the domain of f?
Oh, okay. Go. Keep going.
Then compare the range of f to that of the range of g. Does the absolute value modify the range of f?
Okay. So I have to first find the domain of what? And what? And g. So I'm going to put the domain of f and the domain of g. Now this is simple. Why is it simple? Or theoretically, if we did the last part correctly, why? Danny? Yeah. Yeah. Look. What's the domain? Oh, sorry. Ooh. What's the domain? There we go. What's the domain of sine?
Infinity to infinity. Negative infinity to infinity.
Negative infinity to infinity. So let's write it down. Bam. The domain of f or sine is negative infinity to what?
Infinity.
What's the domain of g? Wait. Are we good here?
Yeah.
Questions? Patty, are you okay? You should rub it around. Okay. Yes.
What are the brackets? Forgot about that.
What are the brackets? So remember, infinity is always parentheses brackets if it's closed or if it touches the endpoint. For example, here the domain of the square root function is from 0 to infinity brackets because it's touching 0. One that would not be touching would be this one. The domain of this one is from negative infinity to 0, union 0 to infinity. Doesn't touch 0. Okay? Domain of G is what? What's the domain of G? The first thing I hit is what?
0.
No. An arrow. Remember, I'm looking at the X, see? Infinity. You see why you want to draw the arrows here? Because you might think it's 0. No. These bounces keep what?
Bouncing.
They keep bouncing, right? So it's from negative infinity to what?
Infinity.
Positive infinity. Perfect. And question. Now did the absolute value modify the domain? No. And you have to answer the question. You would say no. Clearly, when you say clearly, that's a polite way of saying no duh, fool. Clearly, the what? The absolute value did what? Did not what? Change or what? Modify the domain of what? Of which one?
Of G of X.
Of G. Of G. Because the absolute value was on what? Well, no, it was on F. Because G was the absolute value of F, right? So the absolute value did not modify the domain of G. Okay? Or you could say like their domains are the same. Clearly. Clearly their domains are the same. Look at the picture. Right? Look at these. No duh. Okay, next part of the question. Hugo, what else do I have to do? Yeah, compare the range. So range is from where? Range. Yeah, range is from where? Bottom to what? Bottom to the top. And I like Danny said extrema because we actually have extrema this time, right? So let's see what we do here. So now the first, I look here. What's the first thing I hit here? Negative 2. And what's the highest point? 2. Does it touch? Does it touch here?
Yes.
Yes, it does. So, the range of F is what? From, question, Elias, is it brackets or parentheses? Brackets because it touches. From negative 2 to what? Questions on this? Now is the time. Should I go over it again? Is it good? It's pretty straightforward, I think. Range of G. What is the range? Ready? Take your pencil. 0 to what? 2. Okay, I got that. Piece of cake. So that's... Wait, does it touch? Yeah, it does. Okay, wait. Hold on. 0 to 2. Question. Now, let's answer the second part of the question. You have to make sure to answer. Most of the time, every year, people like get it right, or part of it right, but then they don't answer the question. Remember, it said find the range and then answer it. What did I want to know about the range? Did it change the range of F?
Yeah.
Yes.
Clearly.
Yes, clearly, because they're not the same. The what? The range of what? Of G and, we could say, I'm going to do it differently. G and F are what?
Different.
Are different. Thus, the absolute value changed the what? What did it change? It changed the range. The range. I mean, all you have to do is present your evidence and then write a semi-coherent, I say semi because I'm not asking for a lot here, okay? Write a semi-coherent statement saying, look, I know what I'm doing. When you say clearly, that lets me know that, hey, look dude, these aren't the same. Clearly this is not happening, okay? Versus, oh my god, no duh. Those are the same, okay?
But if someone was confident, said clearly instead of wrong answer.
Then I would say, you were not clear enough, okay? Alright, that's good.